All right, welcome to another deep dive. Today we're tackling the core subjects of computer science.
Should be a fun one.
Definitely.
Yeah.
Especially since this deep dive is based on an article by Professor Mukesh Tikwani for his channel, Computer Science Made Easy.
Ah, yeah, great channel.
It's a fantastic resource, especially if you're a student just starting out in this field. It's like having a roadmap to this whole world.
Totally. Because it can be overwhelming at first, right?
Absolutely. There's so much to learn. So let's break it down. Let's start with programming languages, the tools of the trade.
Yeah, good place to start.
Right. What do you think of when you hear programming languages?
Well, it's like, how we talk to computers. It's how we give them instructions to do stuff.
Professor Tikwani focuses on three popular ones: Python, Java, C++ for up, each with its own quirks.
Yeah, for sure. Python's known for being easy to pick up, so it's great for beginners.
So it's very versatile.
Extremely. See it everywhere.
Yeah.
Web development, data science, even AI.
Wow, that's a lot. Okay, so what about Java?
Java's been around forever, super robust, really portable. It can run on pretty much any operating system.
It's big in the corporate world, right?
Absolutely. Enterprise applications, that's where it shines. Big focus on security, too, which is crucial for those types of systems.
Makes sense. Then we have C++.
Now, C++ is where things get interesting. It's all about performance, really getting close to the hardware.
I've heard it's used in game development.
Yeah, definitely. Game development, high-frequency trading, anything that needs raw power and speed.
So why learn so many languages? I mean, it's a lot, right?
Well, it's not just about the syntax. Each language has its own way of thinking about problems. It makes you a more adaptable programmer.
I see. So it's like learning to think differently.
Exactly. It broadens your horizons. Okay, so we've talked languages. Now let's get into data structures and algorithms.
Ah, yes. Data structures, algorithms. Sounds intimidating.
They do, but they're really just ways to organize data and then create instructions to process that data. Think of data structures like containers.
Containers?
Yeah, like we have arrays. Those are like lists, linked lists, stacks, queues, trees.
Okay, I'm starting to get a picture. Why so many different types, though?
Well, each one has its own strengths and weaknesses depending on what you're trying to do. Like arrays are great for storing things sequentially, but not so good if you need to insert something in the middle.
Got it. So algorithms are how we manipulate that data.
Exactly. They're like recipes. You follow the steps and you get a specific result.
Could you give me a real-world example?
Sure. Think about Google Maps. It uses algorithms to find the shortest route. It needs to consider all sorts of data: traffic, road closures, everything.
Makes sense. So these are pretty important.
Extremely. They're the foundation of efficient software. And they come up a lot in coding interviews.
Now I gotta ask, where does math fit into all this?
Math. It's everywhere in computer science. It's the language we use to describe and understand these concepts.
Okay, I'm starting to see the connection.
Yeah, Professor Tikwani mentions calculus, discrete mathematics, linear algebra, probability, and statistics.
All very mathy.
But they're all relevant, like calculus. That's how we understand change in motion, essential for computer graphics and AI.
Like in video games, right?
Exactly. Those smooth movements, that's calculus at work. And then there's discrete mathematics, which is all about countable things.
So like integers and logic.
Yeah, it's the logic behind how computers think. And then we have linear algebra. That's all about vectors and matrices.
Oh, I vaguely remember matrices from high school.
Well, they're used a lot in computer graphics, machine learning, data analysis. They're a big deal.
So math is pretty essential. What's next on the agenda?
Let's go deeper into the machine itself. Computer architecture.
We're going under the hood.
Yeah. We're talking about the CPU, memory, storage, all that good stuff.
It's like understanding how a car engine works.
Exactly. You got to know how it all fits together if you want to optimize performance.
Okay, I'm intrigued.
Right. So if you want to write fast code, you need to know how the hardware works. It's the bridge between software and those physical components.
Makes sense. But what about the software that manages all of this hardware?
Ah, that's where operating systems come in, the unsung heroes.
So like the conductor of an orchestra.
Exactly. They make sure all the different parts of the computer are playing together nicely, allocating resources, providing a platform for applications, all that jazz.
Sounds like they make our lives easier.
Oh, for sure. Without operating systems, programming would be a nightmare. We'd have to write code to interact directly with the hardware, which is incredibly complex.
So what are some key things to know about them?
Well, you got to understand processes, memory management, file systems, and system calls.
Processes, like running programs.
Yeah, basically. The operating system manages all these running programs, making sure they have the resources they need and don't step on each other's toes.
That's a lot of juggling. And what about file systems? Those are just like the folders and files we see on our computers, right?
Exactly. They organize and store data on our hard drives or SSDs. And system calls, those are how programs ask the operating system for services.
Like if a program wants to open a file.
Precisely. Understanding these concepts is key to understanding how computers work on a deeper level, makes you a more effective programmer.
So we've covered languages, data structures, algorithms, math, computer architecture, and operating systems. That's a lot.
It is, but it's all connected, and we're just getting started.
Whoa, there's more.
Uh,
I'm already feeling like I've learned a ton.
just wait till you see what's coming next. We're diving into databases, computer networks, cybersecurity.
And something about AI.
You bet. Artificial intelligence and machine learning are changing the world, and we're going to break them down for you.
Sounds amazing. Can't wait. But before we move on, I want to give a shout out to Professor Mukesh Tekwani and his channel, Computer Science Made Easy.
Oh, yeah, definitely.
His videos are super helpful, especially for visual learners. We'll put a link in the show notes. All right, are you ready to keep going?
I am. Let's do it. All right, welcome back to the deep dive. Last time, we covered some serious ground. Programming languages, data structures, algorithms, even peeked under the hood at computer architecture and operating systems.
It was pretty intense, but super interesting.
Definitely. And today, we're going to keep diving deeper, starting with databases.
Okay, databases, they're everywhere, right?
Everywhere. Websites, apps, pretty much anything that stores and manages information relies on them.
So like social media, e-commerce, streaming services, all that.
You got it. They handle massive amounts of data efficiently.
That makes sense. What are the different types of databases?
Well, a common one is the relational database. Think of it like a spreadsheet on steroids. Data is organized in tables with rows and columns.
Okay, I kind of get it. Why is it called relational?
Because the different tables can be linked together. Relationships makes it easy to find and connect information.
So like, if I want to find all the customers who bought a certain product.
Exactly. Relational databases are awesome for that kind of structured data, but then you have NoSQL databases, which are a different beast altogether.
NoSQL. Like no sequel to the movie.
Haha, no, it stands for not only SQL, they're more flexible, better for handling tons of unstructured data like social media posts or sensor readings.
To like messier data.
Yeah, kinda. They're also really good at scaling, handling huge amounts of information across multiple servers.
Okay, got it. Now, what about SQL? I keep hearing that term.
SQL, that stands for Structured Query Language. It's how we talk to relational databases. We can ask questions, add data, update it, all that jazz.
So it's like a special language just for databases.
Yep. Super important to know if you're working with relational databases. It's used all over the place.
All right, databases, check. What's next?
Let's talk networks. Computer networks, that is. The internet, for example, is a giant network of networks.
Yeah, networks are how our devices talk to each other. Essential for pretty much everything these days.
Absolutely. But there's a flip side, cybersecurity. With all this connectivity comes a whole bunch of new challenges.
Yeah, I'm always hearing about cyber attacks and data breaches. It's kind of scary.
It's definitely a serious issue. These attacks are getting more sophisticated all the time. Financial losses, identity theft, you name it.
So what can we do about it? I mean, how do we protect ourselves?
Well, it's a multi-layered approach. Strong passwords, encryption, firewalls, intrusion detection systems, the whole 9 yards.
Sounds complicated. Guess cybersecurity is a pretty important field these days.
Absolutely crucial, and it's constantly evolving. If you're interested in this area, you got to stay ahead of the curve, always learning about new threats and how to combat them.
Okay, networks and security. Check.
Yeah.
Now, on to something I'm super curious about. Artificial intelligence.
Ah, yes, AI and machine learning. They're kind of taking over the world, right?
It seems like it. But what exactly is machine learning?
It's a way of teaching computers to learn from data without explicitly programming them. They adapt and improve over time, almost like they're thinking for themselves.
Whoa, that's pretty cool. Is it like traditional programming?
Not really. In traditional programming, we give the computer very specific instructions, but in machine learning, we feed it data, and it figures out the patterns and rules on its own.
So we're training it, not telling it exactly what to do.
That's a great way to put it. And there are different ways to train it, too. supervised learning, unsupervised learning, reinforcement learning.
Okay, those sound interesting. Can you break those down a bit?
Sure. Supervised learning is like teaching a kid with flashcards. You give it labeled data, like pictures with labels saying cat or dog, and it learns to classify new images based on that.
Got it. So what about unsupervised learning?
Unsupervised is more like giving a kid a bunch of Legos and saying, go build something. You give it unlabeled data, and it has to find the patterns and relationships itself.
That sounds tricky.
It is, but it's really powerful for things like customer segmentation or anomaly detection.
Okay, and reinforcement learning.
Think of it like training a dog with treats. The algorithm learns to take actions in an environment to maximize its rewards. It's used in things like robotics and game playing.
So the computer learns by trial and error.
Exactly. AI and machine learning are transforming industries, but we got to remember, they're tools. We need to use them responsibly and ethically.
Right, it's not all fun and games.
Yeah.
AI can have consequences if we're not careful.
Absolutely. We need to be mindful of those and develop ethical guidelines for its development.
Okay, so we've covered databases, networks, cybersecurity, and AI. My brain is officially full.
I know, right? It's a lot to take in, but it just shows how vast and exciting computer science is.
And we're not done yet.
Nope. We've still got to talk about the human side of things, the soft skills, the professional development, all that good stuff that's crucial for a successful career in tech.
Oh, that's right. Can't wait to dive into that. But first, another shout out to Professor Mukesh Tekwani and his channel, Computer Science Made Easy.
Yes, go subscribe, people.
Seriously, his videos are a gold mine. We'll be back soon for the final part of this deep dive. Stay tuned. Welcome back. We've covered a ton of ground in this deep dive, haven't we?
We really have. Programming languages, data structures, algorithms, computer architecture, operating systems, databases, networks, AI.
My head's spinning. But in a good way. It's amazing to see how all these pieces fit together.
It is, isn't it? But there's one more piece we haven't talked about yet, the human element.
The human element.
Yeah. Soft skills, professional development, all that stuff that's crucial for actually having a career in tech.
Oh, right. Because it's not just about coding all day, is it?
Nope. Technical skills are essential, but they only get you so far. In today's world, soft skills are super important too.
Makes sense. So what are some of the key soft skills for aspiring computer scientists?
Well, communication's got to be at the top of the list. Being able to explain your ideas clearly, both verbally and in writing, is huge.
Right, because even the most brilliant code is useless if nobody understands it.
Exactly. And you got to be able to collaborate effectively with others, work as part of a team.
Teamwork makes the dream work, right?
Exactly. And then there's problem solving, which, let's be honest, is the heart of computer science.
Yeah, figuring things out is a big part of the job.
For sure. And you need critical thinking, analytical skills, a logical mindset, and don't forget, adaptability.
Adaptability.
Yeah. The tech world changes so fast. New technologies pop up all the time, and old ones fade away. You got to be able to keep learning and adjust.
Stay ahead of the curve.
Exactly. And, of course, time management.
Oh, that's a big one.
Deadlines, complex projects, it's easy to get overwhelmed. You got to be able to prioritize, stay organized, and meet those deadlines.
Good time management is a superpower. So, besides soft skills, what about continuous learning? That's got to be important in tech.
Absolutely. The learning never stops. It's like a treadmill. You got to keep running just to stay in place.
So, what are some good ways to keep up?
Online courses are great. Coursera, ADX, Udemy. They offer tons of courses on all sorts of tech topics.
So much knowledge at your fingertips.
Right. And industry conferences and workshops are awesome for networking, learning about new trends, getting hands-on experience.
It's like a shot of inspiration.
Totally.
Yeah.
And finding a mentor can be a game changer. Someone who can guide you, share their experiences, give you advice.
Like a career Sherpa.
Haha, exactly. And personal projects. Those are great for applying your skills, experimenting, building your portfolio.
It's like a playground for your brain.
For sure. And if you're feeling ambitious, contribute to open source projects. It's a fantastic way to learn from others, improve your coding, and give back to the community.
Awesome. Any other tips for staying ahead?
Industry certifications, they can validate your skills and make you stand out to employers.
Like a seal of approval. So it sounds like a successful career in computer science takes more than just technical chops.
It definitely does. It's a combination of technical skills, those all-important soft skills, and a commitment to lifelong learning.
And speaking of learning, got to give another shout out to Professor Mukesh Tekwani and his channel, Computer Science Made Easy.
Yes, he's got so much great content.
He really does. And he emphasizes those soft skills and that lifelong learning mindset, which is so crucial.
Definitely. So folks, if you're serious about a career in tech, go check out his channel.
We'll put a link in the show notes. Well, that wraps up our deep dive into the core subjects of computer science.
Wow, what a ride.
It's been amazing. We've learned so much, and we hope you have too. But this is just the beginning, really.
It is. The world of technology is constantly evolving. There's always something new to discover.
So keep learning, keep exploring, keep pushing the boundaries of what's possible.
Maybe one day you'll be the ones sharing your expertise and inspiring the next generation.
That's a great thought. Thanks for joining us on this deep dive, everyone.
Until next time.
Happy coding.